Hello, and welcome to the Save It for Parts channel, coming to you from beautiful Sandland, Wisconsin, home of the former Minnesota Zoo monorail, a former NATO radar dome, and in the hillside behind me, the famous Sandland tunnel system. These are DIY tunnels all dug out by hand by Sandland volunteers, and they are now listed on Wikipedia. So Sandland is now in the Wikipedia hobby tunneling entry alongside classics such as Williamson's tunnels, the Forestier Underground Gardens, and other weird hobby tunnels around the world. I think that's a pretty cool thing. We were also recently mentioned on the Practical Engineering YouTube channel, which is one that I watch all the time. I love infrastructure. I love weird behind-the-scenes parts of the physical world, of the built reality. That is just really interesting stuff to me. So to see Sandland on Practical Engineering was fantastic. And Grady over on Practical Engineering brought up a number of safety issues that we've discussed in prior Sandland videos, and I've often answered questions in the comments on my Sandland videos along a very short list of common questions. People ask, will the tunnels collapse? What do we do about air quality? Why don't we have a mine cart? Similar things like that, and I've tried to answer those in prior videos, but the way YouTube works, a video goes up, it gets some views for a few weeks, and then nobody sees it again. The algorithm doesn't push it anymore. So a lot of new viewers, a lot of first-time Save It for Parts viewers and first-time Sandland viewers have not seen my prior videos on air quality testing, on stability, on other historic sandstone tunnels around the area. So I guess it's probably time to do another video on the safety considerations and other practical issues of DIY hobby tunneling in sandstone. So right off the bat, sandstone and sand are two different things. Sand is a loose material like you'd find in a playground or in your cat litter box. It is literally just loose sand. It's individual sand grains. Now sandstone, like this rock face behind me, is actually a bedrock. And in a lot of the upper Midwest of the United States, there are several types of sandstone. There is Jordan sandstone, which we see here, kind of a darker red color. There's St. Peter sandstone, which tends to be a lighter color. There are some other sandstones which are harder and softer, but Jordan and St. Peter are very common, and they are very frequently used for tunneling because they have some interesting physical properties that make them very good for tunnels. Now, sandstone rocks like this one are big chunks of sandstone, and if you don't mess with them, if you don't impact them or wash them with water or hit them with some kind of energy, they are an inert stone. They're a rock. But if you smash them hard enough, they crumble and they turn into sand. If nothing smashes or impacts or washes away the sand grains, then the sandstone is perfectly happy to remain a rock. So we have a face here of sandstone bedrock, and this would basically remain stable for hundreds of years, if not for slow erosion from water. Now that it's exposed to the surface, surface water and rain will very, very slowly erode this exposed surface here, but underground, in our particular tunnels, we don't have groundwater. We don't have storm water or other water utilities washing away the sand grains. So as soon as you get underground, this basically stays stable unless you're actually hitting it with a tool of some sort. Once you do hit it with a tool and smash it out into sand grains, it's very easy to haul out. It's very easy to excavate. So there's not a lot of work required to dig a sandstone tunnel, at least in Jordan or St. Peter sandstone. You don't need explosives. You don't really need mining grade drills. You can just use regular power tools and carts, and the sandstone tunnels remain stable as long as you arch the ceiling just a little bit. So as long as you arch the ceiling on a Jordan sandstone tunnel, it stays pretty stable over years, if not centuries of time. And another reason this works is because our tunnels here at Sandland are relatively small. Even some of the larger tunnels, like my underground speakeasy of the Sandbar here, which is about 6 feet wide compared to 2 to 3 feet of our typical tunnels, this is perfectly stable. Again, it has an arched ceiling. It is not very wide. It does not have a lot of downward forces on it, and the forces it does experience are distributed by the arched ceiling. Now, I've personally seen other tunnels in the same sandstone bedrock in the local area that are 100 feet wide, 100 feet tall, unlined, no supports, no concrete, no shoring, and they've stayed stable again for decades. Now, another factor that actually helps with some of these sandstone tunnels is the ambient humidity. Another question I get quite frequently in the comments is, why is it 100% humidity down here in the tunnels? And that's just kind of the way it is. That's just the tunnel, the sandstone is saturated with water. And if you dry it out too much, it actually becomes less stable. So we don't want to decrease the humidity. We don't want to dry it out. There have been cases of teenagers starting fires in caves in Minneapolis and St. Paul. They dry out the ceiling with the heat from the fire, and suddenly the ceiling falls on them, and then you have kind of a tragedy. So we want to keep the humidity here. We want to keep the walls and ceiling and other parts of the cave saturated with humidity. Even though it doesn't help for filming, you might be able to tell the camera is starting to lose focus because of the humidity in here. The camera is fogging up. And again, for the people who think we're digging in sand, no, we're not. We're digging in sandstone. It's a bedrock. It's a rock. This is sandstone. It's hard to dig. This is sand. And it does take a lot of effort and power tools to turn this into this. Another reason we know the Sandland tunnels are a good design and relatively stable are just from comparison to other nearby tunnels, like those historic sand mines that I've talked about, like other tunnels around the upper Midwest, utility tunnels, storm drains, brewery caves. There are tunnels and mines that have been dug out over 100 years ago that are basically just like Sandland and are still stable, are still perfectly safe, aside from potentially other issues like trespassing. I'm not saying go out and start breaking into tunnels, but we have people here involved at Sandland who have seen probably 90% of the sandstone tunnels in the upper Midwest. They know how sandstone tunnels were designed, they know how they stay stable, what the failure modes are, what failures look like. And yeah, there's a lot of kind of institutional knowledge behind the design of Sandland. It's not just something we pulled out of a hat and decided to do on a whim. Yes, I think it's cool to dig your own tunnels, but be careful about it, be safe about it. Do some research. If you have property with sandstone, find out what kind of sandstone is it, what kind of mines, tunnels, caves exist in that sandstone. Contact your local geology department at your local university or your state, your county, your country's geology bureau and get well records, get geology records, get information about existing mines in that same geology if possible, and find out how old are they? What did they use to dig those mines? How long did they last? What are the collapse issues? Are those mines still stable today? These are all kinds of things you can look into if you're looking into designing or building your own sandstone tunnels. Some Sandland volunteers have even seen tunnels around the world that are thousands of years old in very similar geology. Personal protective equipment is another big thing that maybe I don't focus on enough in other Sandland videos. For example, even though the risk of collapse or ceiling failure is incredibly small here at Sandland, I still tend to wear a hard hat when I'm actively digging. I wear a face shield when I'm using power tools because of flying sand. I wear ear protection because the chisels, the drills are very loud. And almost the most important thing is I wear a respirator, a P100 particulate filter, because sandstone is silica, or at least our sandstone is made of silica, and silica can cause silicosis, which is a lung disease similar to asbestos, similar to black lung in coal miners, and that's not something you want. So when I am actively digging, when I am carving out the sandstone walls, I wear a respirator, which makes my voice sound really stupid on videos, but you know what? I'm willing to take that risk for a little bit of safety. And I do regularly clean and replace these filters so that they continue to work and continue to protect my lungs from the airborne dust. Now, just standing around in here or just walking around in Sandland is not necessarily a problem from a breathing air standpoint. We've had some industrial safety folks out here, we've had some geologists out here, and they've confirmed that the sandstone doesn't really become airborne just by walking around. And part of that is because of the high humidity. Because there's a lot of humidity in the air, dust particles get bonded to water particles, they drop to the floor. So there's not a lot of dust in the air in the Sandland tunnels unless we are actively smashing away at the wall. And then there's airborne dust everywhere. That's when you want the respirator. Sometimes when I'm filming at Sandland, when I'm walking around, you will see stuff in the air. If this were the History Channel, they would call those orbs, and they would say it's because of ghosts, and Zach, what's-his-face, would be all over it. But It's not orbs, it's not ghosts, it's just water particles in the air. It's just fog, basically. Further on the topic of air quality, people have asked, what about just fresh air? Do you bring it in? And yes, we have a vent fan right here at the hull point, and this goes up to the surface. But honestly, we get most of our fresh air just by having multiple entrances. We have 3 adits, or horizontal entrances, going into the tunnel system, and they are at 3 different levels, 3 different elevations. So the warm air from inside tends to come out this one, the upper hull tunnel. Fresh air tends to go in down there at the 3rd adit. And then the original 1st adit also has this grill, this ventilation grating in the door. So even though we keep the door here closed, fresh air can come in from outside. Another common question is, why don't we have a train or ore carts? And we actually sort of do. On the floor here, you will see a wooden railroad track. And this is actually what a lot of mines would have back in the 1800s. If they couldn't afford iron railroad tracks, they would have wooden rails. And down here, parked in the loading area, we have a little train. Now this is a cable-hauled train, so this cable pulls the cars up and out to the surface with a winch. And this loading zone here, you bring your sand, your carts of sand out into the loading platform, dump them through these trap doors or hatches down into the train, and then that gets hauled up to the surface. Now we don't actually use this much anymore because we have a new 3rd adit that is a little bit more efficient. It's a little faster to haul sand out. So the train here is just kind of parked. It doesn't get used much these days. And people have asked about lining the tunnels with concrete. We actually have some test patches here. One of our volunteers, Carl, has tried a couple different methods of applying cement to the walls. If you apply just raw cement, it'll fall off. So he's tried backing it with some chicken wire or mesh, and he's done a couple different test patches here. He's kind of left these in place long term to see which one works the best. I don't know of his entire test parameters, but so far to me, these both look like they're working pretty well. And we might end up using that in some of the larger rooms, or if we want to seal off an area and reduce the humidity, we might end up lining it with cement like that, but that's a future project. That is one of the many, many things we're working on down here that may or may not be completed anytime soon. Another air quality question people ask is about radon, and radon is a radioactive gas that exists in a lot of the US and especially in parts of the Midwest that kind of seeps up out of the ground. If you have a basement in the upper Midwest, you might be experienced with radon. You might have a radon detector or a mitigation system, some kind of fan that pulls that out of your basement. In other parts of the US, that isn't really an issue, but here at Sandland, we do have some radon, and folks have asked if Sandland could be a nuclear bunker or a fallout shelter or some kind of survivalist hideout, and honestly, you'd probably get more radiation if you lived in the tunnels than if you lived outside. It's not a high enough level to be really a problem for occupational use, so just coming out here once or twice a week, digging in the tunnels for 8 hours, you're not getting a significant radon exposure. But if you were living in here 24/7, then it might start to become a problem. So yeah, you wouldn't really want to live in the tunnels. You wouldn't want to use these as a fallout shelter because of that issue. But just for general digging and occupational levels, it's not that much different from working in a basement office in the Midwest. While we're here in the donut room, I should explain some of the only shoring or supports that we have at Sandland. These ceiling supports here. And mostly these are cosmetic. There is one spot over here that has kind of a crack or crevice. So it kind of, it ruins the look of the ceiling. So part of the reason for this donut room, or the idea for this donut room, is it all looks the same. As you walk around it in a circle, you don't really know where you are. There are offshoots going off to the right. After you've circled this once or twice, you're lost and you don't know which offshoot goes where, if it goes to the sandbar, if it goes to the spiral staircase, if it goes out to the exit. Having a crack in the ceiling kind of ruins the illusion. It makes it so there's an identifiable landmark. And so the owner decided to hide that crack, and then to hide the crack, he kind of had to hide everything. So we have this drop ceiling in the entire donut room. Here's an example of one of those cracks or crevices. So this is kind of a natural joint in the sandstone or a fault or something. They're not really a stability issue, and they are kind of a handy way to run utilities. So here I've pounded this pipe through this crack from another tunnel, and so it's kind of a shortcut into this one to run future power lines. We haven't used it yet, but someday in the future we'll run some utilities through here. All right, I think I've covered a lot of the frequently asked questions, a lot of the frequent comments on my Sandland videos. Will it collapse? What's the air quality like? Why don't you have a mine train? I know there will still be somebody in the comments of this video who didn't pay attention to the video and just immediately comments in the first few seconds, "Herpadur, it's going to collapse, you're all going to die." I hope I've answered a lot of the common questions here that you might have about Sandland. And if you do have other questions, please ask away in the comments. Let me know what you think. And I will try to answer those. I do try to read the comments. I do try to answer all the questions if possible. Let's see, water table was another one. A lot of people have asked if we're below the water table or how deep we are. We're about 100 feet underground, but it's complicated because we're under a hillside. So the hill goes like this, we're down in here, so we're maybe 100 feet from the top of the hill and we're 100 feet from the edge of the hill. So to say exactly how deep Sandland is, I would have to look at the surveys and figure it out, but it's probably around 100 feet at some of the deeper areas. Now, we are not below the water table, so the water table locally here is down probably another 100 feet, and we know that from well records. I've pulled county well records. I've found out what are the geological layers that wells go through before they hit water, and we are somewhere in the middle. We have limestone below us, limestone above us, so we're in a sandstone sandwich. We are still a bedrock, but it is a sandstone bedrock, and we don't really have an aquifer right at this level. We don't have water flowing through the tunnels. We don't have any issues with water pooling or flowing or dripping, other than some condensation when I have like warm or cold lights on the ceiling, or I have like a piece of metal or something. That might condense a little bit and we get some dripping, but there's no flowing water in here. And flowing water is an enemy of sandstone. In storm drains, in sewers around Minneapolis and St. Paul, they do have to line those with cement or brick because there's flowing liquid through them, because there is water that can erode the sandstone. There is a stream, kind of a seasonal stream outside the tunnels that really only flows for like a day or two in the spring when the farm fields around us melt, and the water never gets inside the tunnels. All of the tunnel entrances near that stream are either above it or they go in at the stream level and then immediately go up. So water does not get into the tunnel system itself, and we don't have issues with erosion from flowing water. So a few other common questions are, where is Sandland? Do you have security issues at Sandland? Do you have people just showing up and ruining things? Can I come help at Sandland? Can I come live at Sandland? People ask these things. Sandland is in western Wisconsin. I usually don't say more than that. The owner likes to keep the exact location, and if not secret, then a little bit on the down low, just because there are a bunch of idiots on Instagram, and there are kids these days who think they are urban explorers, who just want to go in a location and share it on the internet and draw penises on the walls and basically ruin stuff. And that is kind of what happens to a lot of caves and tunnels in major cities. So we're trying to keep that from happening at Sandland. Other security measures, we do actually have the Instagram kids would have a rude awakening if they showed up unannounced. We also have trail cameras around. We have the doors locked on the tunnels. So Sandland does have some security. I won't go into all the details of it. But if you do want to help out with the tunnels, I usually direct people over to the owner. I am not the owner of Sandland. I'm just a guy who helps out and helps dig tunnels. So I usually direct people to tunnelcity.com, which is the owner's website, and his contact info is on there. So if you're local to the upper Midwest, to Minneapolis, St. Paul, western Wisconsin, if you want to help dig tunnels, contact him. He loves helpers. He does try to vet people a little bit to make sure they're not crazier than we are. I mean, I'm crazy. The owner's crazy. We're all a little crazy. But if we get somebody who's like really crazy, we might not respond to their messages. And every now and then we get somebody who's really crazy. It happens when you have an off-grid crazy underground tunnel system. You get some weirdos sometimes, and there's a certain level of weirdness that even we are sketched out by. Likewise, if you want to live at Sandland or build something permanent at Sandland, the owner is very careful about that because there is a history of people kind of coming out here, building projects or starting projects and then not finishing them. So I try not to be that guy. I try to finish my projects or at least stay active with them, like the sandbar here, like the radome, like the monorail. I try not to start too many things, although it is very tempting to start projects and then not finish them because, I mean, a lot of my YouTube channel is like that. But the owner doesn't really want that to happen, so he kind of wants to get to know people first. If he knows you for a number of years and you turn out to be reliable, then yeah, you know, maybe you can do a big project at Sandland, but that's kind of on a case-by-case basis. And again, I have to refer people to the owner, to his contact info on tunnelcity.com. If you're interested in actually helping out with Sandland, that's the place to go. Another frequent comment is, why don't we use XYZ type of chisel bit instead of whatever I'm using at the moment in a given video? For example, this one's a spade bit. I've also used chisel bits and another more different bit. I actually have 3 of these Extreme Power US chisels. These are like $80 online, and I rotate throughout the digging day with different bits. So as one drill gets hot, I set it aside, I let it cool down, and I switch to another one, and I give a duty cycle of about 10 minutes per drill. So each drill gets 10 minutes of work, 20 minutes of cool down period, and I get to use different bits. So that lets me kind of tailor the different bits to different actions in the sand. I can carve out channels, I can carve out big chunks. So I do use different bits is the moral of the story. All right, so I think that might have covered some of the most common questions we get at Sandland, some of the most common or frequent comments that I get on the channel. If I missed a comment or question that you would like to know more about, then you know, feel free to ask me. Let me know in the comments down below. Do you have a question about Sandland? Do you have a concern? Do you have something to offer? Would you like to come out and help dig crazy weird tunnels? Or if you'd just like to support the channel, if you'd like to support my YouTube stuff, I do have a Patreon, so that's always appreciated. Anyway, I think we're going to wrap this video up. I've babbled on long enough. We've done enough nonsense here for today, so thank you to everyone for watching, and we'll see you next time.